Let's get into some more design problems. So on this one, we've got a designer wanting to manufacture storage bins in the shape of rectangular prisms. So let's go ahead and draw that picture. So we've got some rectangular prism like so. Perfect. And in this storage bin, each will have a volume of 10 cubic feet. The designer wants to choose the dimensions of the bin so that the length is 2 times the width. So I'm going to actually, since the length is 2 times the width, let's say this is the width, which means this is the length, and it's 2 times the width. And we want to make sure that the surface area is minimized. So that's not what I want to just do. Let's make this 2 times the width. Doesn't look longer, but we're going to pretend. We're going to call this the height. So you have length, width, and height. Okay, so we know that we're trying to minimize surface area. So let's talk about how to find surface area of a bin. So surface area is just the area of each face. So we have a face right here that is the width times the 2 times the width. So the width times the length. So that'd be 2w squared. And there's going to be 2 of them. So I'm going to multiply that by 2. We'll clean this up in a second. Then we have another one that's this side right here. And we've got 2 of those. I'm going to actually write that first. So we got 2 times the width times our height. And then our last one is this one. And that is 2. We have 2 sides that are the width times the height. So we've got 4w squared plus 4wh plus 2wh, which is 4w squared plus 6wh. Okay. So we've got surface area. We still have our problem where there are 2 variables over here on the right side because we've got h and w. So that's where volume is going to come into play. So our volume of this specific rectangular prism would be our length, which is 2w, times our height times our width. I did that totally out of in a weird order, but that's fine. So, and we know that the volume, so I'm going to do some substitution, is 10. So 10 is equal to 2w squared times our height. And then if I divide both sides by 2w squared, you get that the height is 10 over 2w squared, or just 5 over w squared. So I can then plug that in to our equation right here. So let's go ahead and do that substitution. So this is equal to 4w squared plus 6w times 5 over w squared. And I'll clean that up one more time just to see what we end up with, and you get 30 over w for our surface area. Since we have a variable in our denominator, that's going to tell us that we need to go to Desmos. So let's go ahead and switch over to Desmos, and we're going to type this in. Well, I should say you don't have to go to Desmos. You can use a graphing utility. I would just use, instead of w, use x for your w when you type it in. Let's go ahead and do that on my page. I've already graphed it. I did it a little out of order, but that's fine. It's the same equation. So just so you know, this y represents the surface area and the x represents your width. Okay, so when we find this value, so I'm going to go right here. I just search around for my minimum because we're trying to minimize it. So it's saying that our width is 1.554 and our surface area is 28.965. So I'm going to go ahead and go back and write that down. So this is from Desmos. I got that the width is 1.554. Now I don't actually need the surface area because we're trying to find just dimensions. So I'm going to ignore the y value. So let's go to and find our height. So our height would then be 5 over 1.554 squared, which is 2.07. And these are in feet, so I'm going to go ahead and put those units down. And then our length is just 2 times the width. So 2 times 1.554, which is 3.108 feet. And that would be the final solution right there with all three of those. So the other two I didn't find from Desmos, just the first one came from Desmos, and then you find the others. Let's try another one of those types of problems. So a company is going to manufacture cans. So we've got a can, and cans are cylinders. So I'm going to go ahead and draw a cylinder to visualize this. And the volume is 1,500 cubic centimeters. We want to minimize the cost. Okay, so we're going to have a cost equation of the materials by minimizing the amount of aluminum used to produce the cans. So really, I should say we're trying to minimize cost, but we're minimizing cost by minimizing our surface area. Because it doesn't tell us what the cost is for all those pieces, but we're just going to assume every part of it, top, bottom, everything is all the same. So we're just going to go ahead and find our surface area of the cylinder. Now when it comes to a cylinder, the top and the bottom are both circles, and you find the area of a circle by doing pi r squared. So there's two of them, multiplied by pi r squared. Then we add that to the middle portion of our cylinder, which if you unravel a cylinder, it's actually just a rectangle, where this is the height, and then the circumference of your circle is the length. So we're going to go ahead, and the circumference is 2 pi r, so that's our length of our rectangle, and you multiply that by the height, which is our width. So it's just length times width. Okay, now we're going to go ahead. We found our cost formula, but once again we're in trouble because there's two variables. We've got r and we've got h. So that's where we're going to use our volume. So we know the volume is 1,500 cubic centimeters, and we know that the volume of a cylinder is pi r squared times our height. Therefore, our height is 1,500 divided by pi r squared. So I'm going to go ahead and substitute that in for my height. So surface area is 2 pi r squared plus 2 pi r times 1,500 over pi r squared. And I'm going to go ahead and simplify that all. So you get 2 pi r squared plus, the pi's cancel, one of the r's cancel, so we get 3,000 over r. Once again, this is not a quadratic, even though we have a squared term because there's that variable on the denominator. So we have to go to our friendly graphing calculator, in my case, Desmos. And I've already done this one, so I'm going to go ahead and pop that one up. So I just need to go around and search, so I'm just scrolling around on my screen. I'm going to try to find it. Seems like things are up here. There we go. Now, just a reminder that y represents the surface area again in this one, and x represents the radius. So we're looking for, and ultimately in this problem, we want the dimensions. So we need to know our height, and we need to know our radius. Okay, so our radius is 6.204 centimeters. So if we, from Desmos, we got the radius, oops, eraser doesn't help, 6.204 centimeters for our radius. So then to find our height, you're going to go ahead and plug it into our equation over here. So 1,500 over pi times 6.204 centimeters. And that's going to give you 12.405 centimeters as your height. So that would be the dimensions.